So let's start. Let's discuss edge computing and microclouds. So today we'll show you that bringing Kubernetes at the edge is literally easy as pie. And that's a good thing you mentioned the slide, because otherwise you won't have get the pun if it wasn't written on screen. Thanks to the star of the show, namely operators, it's not only easy, it's exactly the same as developing applications for any other substrate. Welcome to this Operator Day session. I'm Valentin Viennot, and I'll be running this presentation with Alex Schalkers. Please feel free to use the live chat section to ask your questions during our talk, and don't worry, we'll have time to meet and discuss after it through the networking features of the platform. So before I show you a demo of my home lab microcloud with Juju, 2 words about edge computing. When discussing edge computing, the main questions are usually, what is edge? Where is it? And what size is it? And while there's no right or wrong answers, the real-world applications are inevitably more distributed than the cloud computing will ever be. The software complexity is evolving quickly, and the companies need to innovate at a fast pace in order not to get disrupted. We're not talking anymore about installing CCTV cameras in a shop, but about using machine learning to understand the customer's behavior in the same shop with the same cameras. So the software is getting more and more complex, fast-paced, and tangled. And any business is affected, as by definition, the industries and the real-world applications live at the edge where the customers are. With edge computing, the main challenge is to bring computing near the consumer. In other words, bringing the clouds closer to the users. And these days, by cloud, we usually mean Kubernetes. So before diving deeper into how easy microclouds make deploying Kubernetes clusters for the edge, Alex, can you tell us the story of where do we come from?
Sure thing. Most people know us for Ubuntu. So why do we care about Kubernetes so much? Well, Ubuntu is the platform of choice for the majority of Kubernetes distributions out there. This means that we are very, very well positioned to understand the challenges people are facing with Kubernetes and container orchestration. Whether you use EKS, AKS, GKE, VMware, or Canonical Kubernetes distributions, if you're using it with Ubuntu, you can get support from us. Going deeper into today's topic, Canonical has products that work across what we call the full compute continuum. Each of these domains has its own key ingredients. Each has its own constraints and opportunities. Each has its own Zen, and we focus on enabling efficient operations in each one. We mentioned before that demand for edge computing is currently exploding. This drives significant business requirements for scale, latency, and operations across geographies. What makes aligning over these requirements challenging is that even within a single company, there can be different interpretations of the term edge. We think that it's better to think of 2 distinct classes of compute, microclouds and IoT devices. Of course, Kubernetes can address the entire spectrum, and we can support you with different flavors depending on your use case.
So what are these microclouds? Sometimes they are called edge clouds, and they are basically just small clusters reusing the proven primitives and technologies from the cloud computing to scale down the clouds to the edge. But there are real constraints, such as the device's capacity and accessibility, the repeatability, and the resilience of the deployments. With microclouds, you're trading the exponential elasticity of the central clouds for low latency, privacy, governance, and self-healing of real-world applications. And because of the localizations, but also because of the nature of these applications using our data at the edge of the network, these are non-negotiable requirements common to any edge deployment. To guarantee these requirements, an open source software stack is the right strategy to build microclouds for the edge. And I'm proud to say that Canonical has been investing for years in the core ingredients of this edge recipe, with bare metal provisioning and automation with MAS, distributed and redundant storage with Ceph, scalable and lightweight virtualization with LXD, and containers orchestration with MicroK8s, a Kubernetes that just works. And finally, before heading to the home lab microcloud demo, let's look at the bigger picture and where microclouds fit in. We deliver on the full stack up to secure container images for applications in a fully automated manner and through a completely modular set of technologies where you're free to cherry pick only the pieces you want and integrate them with your existing infrastructure. We prioritize edge-specific features on our product roadmaps to improve the microcloud recipe. As an example, in the latest MicroK8s release, the memory footprint was reduced by 32%, making it optimized for edge devices such as the Raspberry Pi and the NVIDIA Jetson Nano that are very small devices. So all of this is great in theory, but what can you do today? How can you try it now? Using accessible ARM devices is an option that we fully support and that you can use to build and deploy your own microcloud at home. You can refer to the LXD and MicroK8s documentations, as well as the Ubuntu blog for references on how to build it from scratch. But for now, I have pre-configured the setup shown in this diagram, and we'll connect to the cluster and see what we have on all the different layers. You can see on the other video stream that the microcloud is currently running and flashing lights. It's a stack of 4 Raspberry Pis 4 connected through an Ethernet switch. Let me switch tabs and go to a CLI so that we can interact with the cluster. I'm going to use all different command lines to describe what we have in there, and up to the Kubernetes layer. So from the very bottom layer, from the physical devices, we can use the LXC command line to see what devices we have clustered together. And we are going to use the LXC cluster list to do that, to show how our Raspberry Pis are connected together. So you can see that I've got 4 of them here. They are all clustered together in a high available configuration that's shown with the 3 databases replicated through different nodes. So now this is clustering 4 physical devices together to give us an abstraction layer, an elastic layer that we can use as a microcloud, anywhere, including at home. But the interesting thing is what is actually running on top of this cloud. So let's use the LXC list command to see what I've got on top of this LXT layer. So you see that I've got a bunch of machines, or in this case, container named Juju something. We don't have to care much about this because Juju is managing them for us, but you're going to see that just after when we're going to describe the Juju layers. And you see that I've got another one that I deployed myself, which is a VS Code machine. That's actually the one I'm using for the demonstration and accessing from my browser. So now on the Juju layer, what do we have? I'm going to use Juju Clouds to describe what clouds I have connected and available from my machine. So I've got one that I called microcloud. So that's the name I gave to this cloud. That is actually a LXD cluster. That's the one I've just shown before. And for this cloud, I've got a controller running on top of it. That was one of the machines you saw earlier in the LXC list command. This is the microcloud default controller. That's just a basic configuration. On this controller, I've got a few models. You can see here I've got 5 models. So let's use the Juju models command line to actually see what's running on top of this microcloud. I've got, as I said, 5 of them. 2 are the controller model and the default model that is actually empty. And I've got 3 of them that are interesting to us. One we're going to look into later, that is our edge cluster. Let's skip that for the moment. I've got a production cluster and a test cluster. For the production cluster, yes, let's use the Juju status command line to see what I've got in there. So that's my Kubernetes instance I use to deploy my home applications, all the stuff I want to be reliable, that I want to have at home. And I've got 3 nodes to have a high available configuration in case one of the nodes go down. This is what I've got in the prod cluster. And now let's switch to the test one and do the same thing with Juju stages. So you see that I've got the same application, the same MicroK8s application, but this time with only 1 unit. What's super interesting is on the same cluster, I've got 2 different instances, in this case, even 3 of them, of MicroK8s running aside from each other and completely isolated. So that's super useful if you're developing for Kubernetes, for example, and you want a cluster that you can just use to test, to try things, to do a demo, for example, and then you can just throw it away and deploy a new one. In a few comments, you're going to see that later. That's all I have running on my microcloud at the moment.
So, Valentin, quick question on my end. I see your Kubernetes test cluster is running a single MicroK8s Kubernetes instance. What if I wanted to have like a highly available setup, like the one you showed before on your production cluster?
Yes, so that's an excellent question. For that, you're going to need to add units. So as you see, that's a unit of microgates. I've got one, as you said, for this instance of my test cluster, of my model that is called test cluster. And what I'm going to want to do is to add 2 more units. And as I just say it, add units, that's exactly what I'm going to type in my command line. I'm going to use the Juju add unit command line with a number of 2 more units, because you said you wanted a high available configuration. And I'm going to say I want to scale the microgates application. And that is basically it. That's the only command you need to run. And that's going to scale the microgates application, add 2 more nodes, and then you're going to see it's running. I'm going to show you a video of what's actually happening, because it takes quite some time to do. So let me show you the video so that you can see what's really happening behind the scene. So you see, I do the add units, and then we can take from there to watch the stages. And then this is a fast forward of what's happening when you've run the command. So you see that instances, 2 new machines are added that are two LXD container, 2 instances of LXD containers. Then Juju is installing through this charmed operator the packages needed, the snap, doing the configuration, and then doing automatically for you the add node and join the cluster to have all of these nodes clustered together and finally have your high available configuration. So that's what we would have if we have waited, but I have another for you after. And wait, I've got a message. We've got some question in the chat, but I cannot see it. Okay, I don't know, Alex, if you want to take it, because I don't see the question.
Yeah, I see the question. Can we have, for example, K3S units, or must it be microgates? Yes, so right now we're just demoing microgates. So we have a microgates charm, and Juju is using that charm to scale microgates up when you do the Juju add unit. I don't know that we have a K3S charm yet, but if this is something people are looking for, we can definitely talk about creating a K3S charm for sure.
So what's the benefit of using microgates at the edge, and why using microgates with LXD?
I guess so. To answer these 2 questions. Essentially, microgates is a lightweight, pure upstream Kubernetes for workstation, microclouds, and IoT devices. I hope really that everyone here had the chance to experience how easy it is to install during John's previous awesome training session. Microgates can be deployed as a single instance Kubernetes, or it can be used to build highly available multi-node clusters. The zen of microgates is in its minimal ops user experience. Everything can be done through a single command, and everything that shouldn't be the end user's concern is automated. Microgates is also opinionated Kubernetes, which means that it pre-packages the most popular Kubernetes features for things like networking, monitoring, GPU acceleration, and so on. Microgates runs on both x86 and ARM and can be used to build edge container deployments with enterprise support and security maintenance. So now let me really highlight the low-touch user experience for a minute. Everything that you probably want to do in Kubernetes can be enabled with the microgates enable command. These are our opinions, the microgates add-ons, but of course, you can always manually deploy anything else you need on top of Kubernetes and just talk to us about automating the steps. Microgates is, after all, just a standard Kubernetes. So on the LXD side, LXD is really a hypervisor that supports a large catalog of guest images for both containers and virtual machines. It runs natively on Linux and supports the most popular distributions. It also has a CLI client available for Linux, Windows, and Mac OS. LXD is in many ways like a local cloud on your machine that gives you bare metal performance and negligible latency. In microclouds, LXD brings on-demand elasticity and multi-tenancy. You can use LXD to seamlessly provide compute capacity for your VM workloads or your Kubernetes, as we just shown before. Let's now get back to our demo.
Thanks, Alex. So the purpose of this stage of our demo is to highlight how simple things can be while working with the microclouds, microgates, and Juju. So we are going to go back to our LexD cluster with the Juju controller running on top of it. And prior to this action, two Juju deploy commands spun up two microgates instances, one that resembles an on-prem production cluster, the one you saw earlier with the three nodes, and a second edge Kubernetes. So I will SSH into the production cluster and use the microgates enable command to deploy the portainer on top of it, which is one add-on that you will see later. And finally, I will use the Juju deploy to deploy the hello kubecon charmed operator from the previous session to have some container workload on top of my Kubernetes layer. Alex, do you mind saying a few words on portainer and how it's going to be used in this case and why is it so an interesting example?
Yeah, sure thing. So Portainer is a management tool that allows you to group and manage Kubernetes cluster and containerized applications on top of Kubernetes in a single interface. You can use the Portainer dashboard to do things like standard application deployment and manage network configurations. But what we will do in our demo is that we will use the Portainer dashboard to essentially register the edge Kubernetes node that Valentin listed before to phone home to the production cluster. So that's a standard use case that we can see in Kubernetes at the edge. And what's really interesting is that Portainer enables you to phone home with the edge cluster without knowing its IP. So let's see how that is implemented.
Awesome. Okay, it appears that I've got a hardware failure, and I'm going to say useful thing that John told me backstage that SD cards can't be relied on. That's super true. So I've got the Raspberry Pis that are actually rebooting at the moment. I'm not quite sure what we're going to be able to show. So let me, at least for the Portainer part, show you a few videos that I've got pre-recorded so that we can actually show you something. And sorry about that. Is the video playing? All right. I'm gonna speak over it if it wants to play. Okay, that's a fun thing that both the demo and the backup video are not working. That's when you need a plan C.
There you go. I think the video is loading. It's all good.
Yeah, all right. So as told before, the first step is going to be to actually install the Portainer add-on through the microgates enable command. And to do that, we're going to use the production cluster. I think this video was just to show what was on the edge cluster, wasn't it? Exactly. So this one is actually about enabling the access. Damn, today is definitely not my day.
It's all good. The demo goods are not in our favor today, but yeah, we'll manage.
All right. I see that things are rebooting in the background, so hopefully we will be able to show you how to deploy your charmed operator that you developed with John earlier on top of your microcloud. Okay, that's right. So switching on the production cluster is the first step. Then you can use Juju status to see what machines you have actually running on top of your, in your model, and use one of them. Doesn't matter which one because they are just clustered together to actually run the microgates enable Portainer command. In this case, because we want to enable Portainer, but as Alex shown you, that there's a few more add-ons that you can enable with this command.
And essentially what the add-ons do is they abstract all the complexity you're having to deal with configuring and deploying applications on top of Kubernetes in the pods. So you just get a full deployment of the different add-ons just with a single command. So this is really highlighting the simplicity of microgates.
Exactly. I'm always using the one to enable the dashboard because it gives you like a Kubernetes dashboard in one command, accessible, and that you can use immediately. That's really useful if you like great UIs, as I do. All right, so what you've seen in this step is that the portainer enable actually did the commands and the configurations on the cluster. So what you can do right after this is to check what was on top, what was actually done on the cluster. So in the video, I've done the configuration of my local kube control command line as well, because I didn't do it before. This is something super common if you're already using Kubernetes. If you're developing with Kubernetes, you know that super well. If not, don't panic looking at that many lines of YAML. That's just the configuration to tell Kubernetes how to join the cluster. And as you see, once you pasted it in the right file, you've got access to the cluster. You can list, in this example, the namespaces. And you can see that portainer has added a new namespace. That's where you're going to find the pods and the services that portainer has deployed. In this case, what was interesting was the service, just to know on what port you could access the portainer dashboard. Then you have to grab one of the IP addresses of your Kubernetes nodes to actually access it. And you see you've got a brand new portainer dashboard that you can configure for the first time. You can tell it to use the Kubernetes local environment. And that's it. You've got a super dashboard to manage all of your clusters in one place with your main one already in there. And I'm going to use the next one to pause on this view because there's something interesting to discuss there. You see that we've got 3 nodes on the right, and all of them are grouped together, giving you all the compute and memory that you need, that you can access through this clusterization. So what we said we were going to do is to add an edge endpoint and register it against your central cluster. So to do that, you've got the endpoints menu on the left, and you can add an edge agent. So exactly as Alex said, it's a good solution here because you don't know the IP addresses of your edge nodes or edge clusters. So you want them to phone back home instead of registering all of them in one interface. So that's exactly what you're able to do with this. And you can see that after a few seconds or minutes, the cluster is associated and accessible from your central dashboard.
So what's also interesting to see here is that if you look at the local Kubernetes cluster, which is essentially the production cluster, as Valentin called it, you can see the different CPU and memory aggregations from all the different Raspberry Pis. So this is really good. Like you can see that it's actually a cluster of 4 different Raspberry Pis, and that they're grouped together in a single view on the portainer dashboard.
So I'm going to go back to our cluster because I see that it should be up again. The Raspberry Pis are hopefully very quick to reboot. And I'm going to do the second part of it.
Let's do some live stuff instead of showing this video.
Yes. So the second part is actually the most interesting for you. You've done a charmed operator just earlier with John. So that's great, but what are you going to do with it? You're going to deploy it maybe on the cloud, maybe on AWS, maybe on Azure. That's all fine. But what if you want to try it locally on your microcloud? You're going to say that's super easy. So let's say you start from a Kubernetes command line that is already configured as we've shown in the videos. So that means you can do your kube control get nodes and that it runs without exceptions. You see here that I've got my 3 nodes because it's the production cluster I described earlier. And right from that, you're going to add a new cloud to your Juju configuration, to your Juju controller in this case. So let's use Juju add K8s to add a new Kubernetes cloud. I'm going to call it edge cluster because that's what it is. And that's it. That's basically it. Because I've got my kube control command line configured locally, Juju is just going to pick up the credentials from it and register this new cloud in my configuration. So let's wait till that happens. I'm going to tell to put it on the controller only, so I don't have to bootstrap it. That's just to save some time. And that's it. I've now got, if I do my Juju clouds, I've now got a new cloud that is called Edge Cluster, as you see, and that is a type Kubernetes. So what's super interesting here is that Juju can access all the different layers, right? Like in this case, I don't have mass configured, but it could even access the bare metal deployments. It can deploy on top of LXD containers and machines, and it can deploy on top of your Kubernetes clusters. So let's actually deploy something on top of it. I'm gonna clean my screen so it's better for you. And I'm gonna do a Juju add model. It's the space where I'm going to deploy whatever I want to deploy. I'm gonna call it KubeCon because that's what's coming up. And I'm gonna select the edge cluster that we've just added as a new cloud. So the model is now ready, and the next command is, you've learned it in the session right before, Juju deploy, the name of your charm operator, in this case, hello KubeCon, I think it is, and run this command. So what is actually happening is that Juju is deploying the operator on my microcloud on top of this microcates layer. We're gonna see that with the Juju status command first. You see that it's deploying the application hello KubeCon. It's actually in status waiting and installing the agent. Let's actually check in the cluster what was done. Kube control, I think I need a namespace, right? Yes, I need the KubeCon namespace, kube control, get all, and in the namespace KubeCon. You see that I've got my operator and my pod for the hello KubeCon application that is currently initiating and launching. And that's it for this demo. That's all I had to show because you already know what's next. The goal was just to show how you can get a microcloud super easily. Let me share a few last slides. Okay, so what have we done actually? Something we haven't seen. It's this snap install microcates command. We haven't seen it because it was done in the background by the charm operator on top of the LXD machines that were spun up by Juju, by the Juju controller. In the case you want microcates on a device, or you want to set up a small cluster yourself, you can actually do it with this super simple command, snap install microcates. This can be done in a high available configuration as long as you've got more than 3 nodes, and there are many add-ons to add, such as Portainer or the Kubernetes dashboard that you can just do in one microcates enable command. In case you want a full microcloud, you can do it with a few Juju bootstrap, add model, deploy, and relate commands. And LXD clustering gives you cloud elasticity and allows you to get on-demand microcates clusters for development, test, and production use cases. Scaling up and down is super easy as the operator lifecycle manager does all the work for you. Finally, the open source microclouds are the way to go at the edge, and you can cherry pick from our technologies to build this stack entirely supported by Canonical. This is the end of the presentation. Thanks a lot for your time, and hopefully you all want to build your microcloud at home now using LXD and microcates. And you can learn more on these technologies and other techs on our websites, and also find cool videos of our demos on our YouTube channel.
And of course, feel free to connect with us on social media, find us at our booth during KubeCon, and definitely don't miss the chance to fill in the Kubernetes and Cloud Native Operations Survey for a chance to share your insight with the community. And who knows, you might even get to win a charming t-shirt, like the one that John was wearing this morning. For those of you that are interested in meeting with us, there's now a 30-minute networking session available through the Hopin platform. So if you look at your right-hand side, there's this little networking option on the side menu, and then definitely join the community session about building a module-driven operations manifesto with Mark Shuttleworth and Ken Sipe. That also starts in 30 minutes. So we hope to see you all there. And now let's see if we have any questions on the chat. I think I saw some of them. There were some good questions about micro-K8s. All right, so Michael says, if I understand correctly, K3s compiles out alpha-level features to reduce footprint. What about micro-K8s? Does it maintain feature parity with vanilla Kubernetes? Yes, absolutely. Micro-K8s is pure upstream Kubernetes. The only thing that we do is we take the upstream binaries and recompile them into our packaging, and that's it. There's nothing more to it. But all the services are there. Yeah, so we do have feature parity with vanilla Kubernetes. Let me see. There's another question of Bart. Does having micro-K8s clusters on top of LXD clusters not break anti-affinity? Well, the answer is yes, but then right now we're sort of demoing a homemade lab sort of setup. So if you want to have respect for anti-affinity rules, you would probably not run your database master and your slave on top of the same hardware. So right now we're sort of tinkering our way and having like a cool demo setup, but of course we would respect the anti-affinity rules where that matters. So I guess, Valentin, there's another question for probably you. Do you feel Raspberry Pis are ready for production edge clusters?
Today I don't. 1 week ago I did. I guess the problem in this case is really what you're using with them, how you configure them. But yeah, I'm gonna say that Raspberry Pi is probably not a production device, depending on what you want to do. Like it can, I think for IoT it can be, but please take in consideration that in this demo we had more than 7 instances of micro-K8s running on 4 small Raspberry Pis. So that's quite a lot.
Yeah, it's pushing it to the limit.
Yeah, and they've been doing this for all the weekend, you know, and all day today. So I think that might be a bit overheating as well.
Yeah. But then, of course, we have been seeing a lot of really cool sort of homemade demos of combining micro-K8s and LXD and a few other things from the Canonical tech stack where you can really create nice sort of appliance type of setups and experiment with our tech and Raspberry Pis. I don't think I see any other question. So we might still hang around a little bit further here, just in case any other question pops up. And then I guess Mark and David will join again for the community session. Oh, there's the one. Do you have a plan to have cloud controller for your LXD substrate to provide correct node AZ labeling?
I wouldn't know how to answer these questions. I think we can.
Yeah, I think that's a question for the LXD PM. Michael, I'll be happy to forward your question to the LXD team and get back to you on this one.
I've got a question for Leanne as well. When I was talking about having a retail store, I was thinking of a single masternode, or what would be an example of how your infrastructure is set up. That's a great question. It really depends what hardware you're using. Usually our configuration that we promote for microcloud is at least 3 nodes to have the same elasticity and the same primitives that you would have, you know, with a cloud, basically. if you only have one node, that's kind of hard to call it a cloud. You don't have high availability. You don't have this elasticity, flexibility. I'm trying to find other words because I just keep repeating the same elastic word, but that's basically what it is. But I know that it can be expensive for like thousands of stores to have 3 nodes of some quite expensive device. So it can be that you will find some one node clusters that you can still call in this blurry space between what is actually IoT, what is actually microclouds. So that's not like we could give a definitive and final answer. But usually we would recommend to have at least 3 nodes, so you have this at least these high available configurations.
And there's David.
That it has been quite a day so far. The APAC session, the Euro session, and US session coming up. But before that, we're going to do the community session with Mark Shuttleworth and Ken Sipe, where we talk about operators, model-driven operations, and start moving towards possibly building a manifesto. It might be one of those sessions where it's one of those birds of a feather where you come out of it saying, I was there, I was at that one. So that's coming up. I think a few people are through some networking, and that's fine. We've got another 20 minutes before the community session is ready to get going. So if you have questions for Alex or Valentin or for John, they're all still around. We've got the...
I see a new question popped up, sorry.
Yeah, there we go.
And Valentin, I guess this one is for you. What's the minimal footprint for your bare metal microcloud? That's an interesting one.
So that's a complex one to answer. It really depends what kind of configuration you want. I know that I've seen some super lightweight, super minimal configuration with only microcades installed on top of the device. So you just keep the LXD layer, and then it really depends what you want, because if you want a Kubernetes layer, you will want to have some microcades on top of it. If you don't care about Kubernetes, you just want to have machines on demand, you can just use the LXD layer, and it's super lightweight. Like it comes built in with Ubuntu, and it's basically adding nothing in terms of footprint. So it really depends on the configuration. I don't know if I misunderstood the question as well. Could be.
Here, Valentin, do you need an extra server for MAS?
Yeah, and unfortunately, the support for Raspberry Pi with MAS is not neither official, neither stable. Not that my configuration was stable anyway, but yeah, you would need an extra server. You can, in this case of 4 nodes, you can pick one of them to be the MAS. I don't know if MAS manager is the right name, but whatever, or to have an external machine that is doing this role, that is maybe a smaller machine because you don't need much compute.
All right. It looks like there are a few people getting started in the community session over here. They are grabbing some dots and moving them around. So we're definitely looking forward to that. I can see that Ken is in the room. So he's looking around to see what people are curious about hearing him and Mark Shuttleworth talking about. If you'd like to, the links are already shared in both the event and the stage chats. But like we said, you've still got 20 minutes before that session. If you need a break, now's the time. Otherwise, feel free to take advantage of the networking options and meet some of the other attendees and Canonical around.
All right.
So Valentin,
you're join the networking session as well, just to have the chance to hang around with our audience. So I'm going to drop here. See you guys.
Valentin's going to go and build some more things on top of Raspberry Pis.
Exactly.
So
see you, David. Thanks.
Awesome. See you soon.